Right, we have Anna and Eric, and they're leaving their homes and going to meet up in maybe for a cafe or snack or something. They're both leaving their homes at 1 o'clock. You can see that their journey starts there. At 1 o'clock, Eric leaves his house and he travels 20 kilometers and he arrives at 2 o'clock. Whereas Anna starts at 50 kilometers away from where Eric's living, but she meets him up at the cafe 30 kilometers later. She's traveling 30 kilometers, 50 minus 20, 30 kilometers. They meet for half an hour until 2:30, and then they travel back to their respective homes. So Anna's trip can be represented like this. She goes first to the cafe. Time ticks and she's actually not traveling anywhere while she's maybe having a coffee with him. And then she makes her way home, which can be presented like this. Eric is doing the opposite. He's just going 20 kilometers, meeting at the cafe, and then he's going home. And there was a number of questions they wanted you to ask. What time do Anna and Eric meet? Well, this is the point where they meet, so we just read up the graph, or read down from the graph at the meeting point, and read off the time, off the x-axis. So don't forget to answer the question. They meet at 1400. Answer A. Then it says, how far has Anna travelled? Well, Anna travels 50 kilometers minus the 20 kilometers to get to the cafe equals 30 kilometers. So Anna travels 30 kilometers to the cafe. Then it says for question 3, how long do they meet for? Well, in order to see how long they meet for, we have to see when they start going back to their respective homes. Read off the graph here. So they're meeting from 2 till 2:30. So C, they meet for half an hour. Half an hour or 30 minutes. Doesn't matter which one of those you choose. Then it says, when does Eric arrive home? And they're cheating you a little bit here by only putting in the time 1500. But you can read off the graph that each of these is 15 minutes, and he's got 2 more of those distances before he gets home. So he actually gets home at the time 15:30. So Eric arrives home at 15:30. At 15:30. Then it says, what's the speed of Anna and what's the speed of Eric? Well, if we take Eric's speed first, speed we calculate by taking the gradient. And the gradient of this line is we take the difference in the y-axis, so how long did he travel? And this is a really, here we can see that he's traveled 20 kilometers. And we divide it by the time that has passed for that speed that he's traveled. So he started here and he stopped here. So the time was from 20 kilometers down to 0. That's 20 kilometers. And the time was from 14:30 to 15:30. So that's 1 hour. The difference in the y-axis is this one here. So we take the difference in the y-axis divided by the difference in the x-axis, and it will give us the gradient. So the speed for Eric is the difference in y-axis divided by the difference in the x-axis. This is what we call the gradient. And it's y2 minus y1 divided by x2 minus x1. y2 minus y1, we decided to take it between these 2 points here. The difference in the y-axis up here is 20, and the y-axis down here is 0. So 20 minus 0 divided by the difference in 330 minus 230 would give us the answer in hours. So we get 20 divided by 1, so we get a speed of 20 kilometers per hour. So Eric travels at 20 kilometers per hour, and that's how you use the graph to calculate that. For Anna then, well, the difference in the gradient here, we're going to take Anna's curve, and we're going to expand this here. Whoops, not very straight, sorry. We say, what's the difference in the y-axis between 50 kilometers and 20 kilometers? It's 30 kilometers. For 50 minus 20 is 30. So for Anna, we get y2 minus y1 divided by x2 minus x1. Here we have 50 minus 20, the difference in the y-axis, divided by the difference in the x-axis. Here we have 1 hour. It's the same time difference, 14:30 to 15:30, the time difference is 1 hour, divided by 1. So we get 30 divided by 1, which is 30 kilometers per hour. So you can use your graph to get the speed, and that's really what the SVT formula is. That's basically what it's doing. It's dividing the distance by the time. And you're doing that graphically in this particular question. So gradient is always the difference in the y-axis divided by the difference in the x-axis of the points. And it wouldn't have mattered which, let's say that I'd chosen a different, let's say that I'd taken half an hour here. What would I have got if I'd taken half an hour? Well, my distance for half an hour would have been 50 kilometers divided by half an hour. What's 15 divided by half? That's the same as 30 divided by 1. So I'd have got exactly the same speed, even if I'd chosen a different point on the graph. And that's the beauty about graphs. That it doesn't matter which point you choose, as long as you divide the difference in the y-axis divided by the difference in the x-axis, you will get the correct gradient. Okay? How steep the graph is.